Here question number 3a. Which isomer of C5H10 gives a single monochloro compound C5H9Cl in bright sunlight? So from the question you can understand that. So in bright sunlight halogenation is taking place. But single monochloro compound means so all carbons must similar type, then only it is possible. So C5H10, if you take it as alkene, because alkane general formula CnH2n plus 2 means if you substitute this value C5, so 2 into 5 10 plus 2 means H2L. So this is not a open chain structure, so this must be a cyclic structure. So if you take cyclic structure of 5 membered, so that is going to be like this. So which means I am going to write like this: CH2 CH2 CH2, here CH2 and here also CH2. Now C5, each carbon is having 2 hydrogen, so C5H10 it is fulfilling the criteria of the given molecular formula. So when you treat this with Cl2 in presence of H nu, so anywhere you can write 1 chlorine, so that formula will be C5H9Cl. So this IUPAC name of this compound, if you give the numbering 1 2 3 4 5, 1 chloro, because it is a cyclic compound, cyclo, and 5 membered, so that is 1 chlorocyclopentane. This will be the answer. Next B question answer. So arrange the following compound in increasing. Arrange the following compounds in increasing order of reactivity towards SN2. So here SN2, 2-bromopentane. I am going to write the structures. 2-bromopentane means 5 carbons, we need to write 1 2 3 4 and 5. Second carbon, suppose here bromine, you need to balance the valence of 4, so one bond is finished, so CH3 1 2 3 finish, 1 hydrogen I am writing here, 1 2 means here 2 hydrogens, 1 2, here 2 and here 3. So this is a 2 degree, this because this carbon is attached to 2 carbons, so one is this one and other one is this one, so 2 degree carbon. And here 1 bromopentane means 1 bromopentane, again 5 carbons, 1 2 3 4 5. So at first carbon bromine means 1 2 finished, remaining 2, 1 2 finished CH2, 1 2 CH2, 1 2 CH2 and CH3. So this is 1 degree. And third one is 2 bromo 2 methyl butane. Butane means 1 carbon, 4 carbons, right? So at second carbon bromine as well as 1 methyl. So 4 is finished, now CH3 and here CH2, here CH3. This alkyl halide is 3 degree. So according to SN2, so SN2 should be going through a transition state and 100% inversion products we are going to get. So inversion with less steric hindrance. So the less steric hindrance will be 1 degree, then 2 degree, then 3 degree. So if you write the order, what in the question he asked increasing order of reactivity, so highest will be 1 degree. So we can give the number, this is A and this is B and this is C. So least will be 3 degree, means C is lesser reactivity, then A, then B. So this will be the increasing order of reactivity. So in question number 3, why para dichlorobenzene has higher melting point than those ortho and meta isomers? So we need to write the structure. See answer. This will be the para dichlorobenzene, and here Cl, here Cl, this is ortho dichlorobenzene, and whereas meta is like this, meta dichlorobenzene. So when you take this one, so para dichlorobenzene, if you take this compound, so it is symmetrical in nature and in crystal lattice it will be fits perfectly, right? So in crystal lattice it fits perfectly. So intermolecular forces will be high. So intermolecular forces are very high. Hence, it is difficult to melt. Then it requires a lot of energy, right? So since it is this structure is very symmetrical, so this structure is very symmetrical, so what is going to happen, this is going to fit perfectly in the crystal lattice. So the distance between two adjacent molecules will be very close, so intermolecular forces is going to be very high, so it is difficult to melt them, because the breaking of this intermolecular forces we required to give lot of amount of energy. So that's why compared to this ardo and meta dichlorobenzene, para dichlorobenzene's melting point will be high. And the last one, so identify A and B. So here the compound, this one, yeah. So in presence of magnesium dry ether, so reaction with metals haloalkanes, so simply what we are going to do, so we need to insert mgbr, this is a, so it is subjected to hydrolysis, I guess, yes, hydrolysis. So hydrolysis means H plus OH minus. So in RMGX compound we know that here negative charge, here positive, so we need to give this positive here and negative on this one, right? So this is the compound B, and byproduct will be Mg, here Br, here OH. Thank you.